Ladies and gentlemen, welcome to the DTDCH webinar on lighting color accuracy and creative lighting for museums, libraries, archives, and other cultural heritage institutions, as well as those of you doing commercial art reproduction and commercial digitization for cultural heritage institutions. I am going to be your main host today, and I'll do introductions to our co-host, Robin Myers, in a moment. But first, a few housekeeping notes. Please, if you have questions after the webinar ends, or if you prefer to have your questions privately answered as opposed to in front of the group, please contact info@dtdch.com or your DTDCH salesperson. If you are not in the U.S., if you are located outside of the United States, please contact your Phase 1 Cultural Heritage dealer so you can receive local support in your local language and a little bit closer to home. So our agenda today is going to be quite simple. We have introductions that will be quite brief. We have a presentation on lighting technical color accuracy. That will last for between 40 and 50 minutes is our anticipation. We will then have a time for Q&A on that section, followed by a section on lighting and creative techniques. On to the introductions. My name is Doug Peterson, and I work at the Digital Transitions Division of Cultural Heritage as one of the technicians or research and development people. I like to call myself one of the nerds. And digital transitions there was a small technical glitch there. Let's continue. The Digital Transitions Division of Cultural Heritage is a company that provides hardware, software, and consultation for digitization in cultural heritage, color critical, and other applications. As you can see, we provide a wide variety of hardware, including the BC100, which you see on the left. That is a 2-camera, pneumatically driven, conservation-friendly book cradle that allows us to capture both left and right pages in a book simultaneously, all the way down to the DT Atom, which is our smallest and most versatile system. That is what we'll be using throughout the presentation, the second half of today, on creative lighting. We also make a variety of other systems, including the central item here, which is our film scanning solution. That can replace a drum scanner or a flatbed scanner to scan anything from 35mm mounted slides up to large format glass plate negatives, lantern slides, hand-cut film, and more. Let's introduce some of our development offerings. We like and pride ourselves on providing more than just hardware and software. We like to be able to be part of the community. We like feedback from the community, and we like to educate our clients and participate in the education of us via our clients. And to that end, we offer a variety of professional development offerings. Last year, in 2015, we had 3 webinars. These are present on our website for free. So we have one on capturing cultural heritage, one on film scanning, one on process control, and an IS&T short course that we did on Apple scripting. We also ran a roundtable here in New York and wrote a guide called the Digitization Program Planning Guide. If you've not seen this, you can go to dtdch.com, and it's there along the top. It is a fairly comprehensive guide to either starting up from scratch or building upon an existing digitization program. And it includes some of the more technical elements, but it also provides a lot of advice from our clients, collected as quotes from our clients on some of the more practical elements, like how to keep the individuals doing the digitization happy and how to keep their workflow varied, things like ergonomics and practicalities of handling the politics between various divisions of an entity that may not have all the same goals when it comes to starting or improving the digitization program. We'd really encourage you to read that. We also did a Phase 1 Cultural Heritage Specialist training, and we will be having a few more of those coming up. Today we have a webinar on lighting, as you know. And coming up in the short term, we have in June and July 2 more Phase 1 Cultural Heritage Specialist trainings that will be happening in New York and in LA. Those are 2-day classes, and they are pretty comprehensive. They're both good for our existing clients and for individuals who are considering switching to a rapid capture solution for digitization. We'll also be teaching a short course again this year at IS&T, this time on auto cropping, and we also have not listed here a presentation we will be co-presenting at DPLA. So if you're at either of those conferences, DPLA or IS&T, look us up. And then finally, in the future, we hope to have a finalization and a release publicly of our program that we're starting called the Digital Transitions Digitization Academy. This is a multi-tiered educational offering, providing everything from very basic entry-level information for university students who are interested in digitization and what is going on in the modern era of digitization, all the way up to Tier 5 classes for those who are already experienced and extremely savvy in digitization who want to explore some more advanced techniques like multispectral imaging or uneven textural enhancement and that sort of thing. So now I'd like to turn over to Robin Myers, who will introduce himself and his past, present, and future. Robin, look into that crystal bar for us.
Hi, I'm Robin Myers. You may know me from Robin Myers Imaging. I've been involved with color science from both a theoretical and a practical standpoint for many, many, many years. And I worked at Apple Computer, where I received several patents on color matching technologies. And then I recently did a long time at DayLite, where I worked very closely in solving some problems for the cultural heritage area. You may know me also from my Spectrashop program, and I also made color targets for the AIC, American Institute of Conservation, and gray cards and EquaLight program for photographers. So I had my hands in all kinds of things from soup to nuts in digital imaging.
And what are you up to now, Robin?
Up to now, I forgot. For a year now, I've been working with Northlight Products to come out and develop a set of lights, which the Digital Transitions Cultural Heritage Division sells, which are extremely high color quality LED lighting, so that we can get the best color possible, and also without any UV or IR to damage the artworks. So
Very
that's
good.
what I've been doing for about the last year.
Well, Robin, I think you know they didn't come to hear about us, you and me, but they came to here to talk about some lighting technical topics. So let's jump right in, shall we?
Okay.
So the first section of today, again, lasting about 40 or 50 minutes, is going to be on technical merits of lighting, and specifically on color accuracy, because really. So to start off with, we need to address the question of what is color. And it's really funny, I got to tell you, every explanation of color you've ever been given, whether it's a two-sentence cutesy answer from your parents when you were a kid, or a multi-hour lecture from a professor of physics in a PhD level, it's been an oversimplification. Color is an extremely complicated and deep topic, and so including the presentation today, every explanation you've been given has been a simplification of the whole. But with that said, I think it really does merit conversation about, at the base of it, what in fact is color. So when we talk about color, what we have to understand is that color is a sensation. It's something that we perceive or experience and not an objective reality. Color is something that we manifest in our brains through our eyes and that we experience in the same way that we experience sound, taste, or smell. But there are some differences, and the most important for today is the fact that with most of what we experience in life, we can both experience the components and the whole. As an example of this, a musical chord, even if you're not especially musically savvy, if you listen carefully, you can hear each individual note in a musical chord. So for example, I'm going to turn up my volume here on my favorite little app, GarageBand. So what you hear there is the chord. You hear the vibrant, coherent, pleasant sound of the total chord, but you also hear each individual note. If you're not musically trained, you may have a hard time picking them apart, but you can hear each of them in there. If I change one note, you can hear that change. So here we go. Now I'm going to change one note. Even if you're not musically inclined, you can hear that change as well as the change to the whole, the chord. So with musical chords, we experience both the individual components and the whole, but this is not the case with light. This is what really makes light so complicated to learn about, experience, and work with. With light, all we experience is the final effect of the color. We do not see, experience, and cannot pick out the individual wavelengths that make it up. In fact, because of this, there are situations where you have two different lights or two different objects that appear to be the same color, that you perceive as the same color, that have wildly different spectrums. And here's an example of that drawn off in a chart. So on the left side, you see two separate spectrums, light 1 and light 2, listed as black and white lines. And you see that, for instance, between 520 and 560, light number 2 has quite a bit of energy. If we look at light number 1, it has a broader space of energy around the same general area, but in a different place, between 560 and 600. Again, light 1 with black has a lot of energy between 640 and 680, while light 2 has a lot of energy between 680 and 700. If you're not following along with the exact numbers or the sort of minutiae here, what's important to understand is that the individual components of this light are different. But then when we add them up in our head, what our eye says, what our brain, optical brain system says, is these are the same color. Now this is a pink color, so these lights would both be, for instance, lights you might use on a DJ floor, a DJ dance floor, but they both are perceived as pink. And moreover, it's really important to use the right verbiage there, because it's not that we are mistaking them to be the same color or can't see the difference in color. There is no difference, because what we perceive is the color. The color is what we perceive. We only see that whole, the color, and not the spectral components. So if spectrums are such an important part of understanding color, if they are such an essential part of how color is interacting with objects and with cameras, and we can't see spectrums, how are we going to measure them? How are we going to pay attention to and tear apart which lighting has good spectrum versus bad spectrum, has a good spectrum versus a bad spectrum? And for this, I thought nobody better in the world to present than Robin Myers, who has spent a career designing software and doing consultation on literally the metrics of lighting. So I'm going to turn it over to Robin.
Okay. As you can see in the slide that we have here, color has a variety of terms that are associated with it. Generally, we start off with simple terms, like is the light warm, cool, hot, etc. But that doesn't tell us much about what we perceive with the light. To do that, we try and define some terms which have a little bit more science behind them, such as color temperature, where we can say that it's a 5500 Kelvin light, or it's a 6500 Kelvin, or it's daylight balanced, and so forth. And that tells us a little bit more, but it still doesn't tell us enough to understand how that's going to help us or hurt us. We can go up to using spectral-based methods such as CRI and CQS, and those take us another step further. But again, we need to have a little bit more understanding to go with that. With color temperature, it's really, we're saying is that number, that Kelvin number, is sort of an equivalent color to what it would be if we heated up a metal and we looked at the light that that metal emitted. And I'm sure you're familiar with seeing things like a red hot or blue hot or white hot metal. And those correspond to different amounts of light coming off in various parts of the spectrum. And we can relate a color light source to that kind of equivalent general color. But it doesn't tell us, is it cool, is it warm, unless you knew about that. And so it takes a little bit of knowledge to understand how to use it. And it still doesn't tell us if that's going to make a good picture or not. So in the 60s, they came up with something called color rendering index. And you'll see it on all the light bulbs when you go down to the home store and get your lights. The color rendering index, in its simplest form, uses 8 patches. These patches are all mid-lightness, mid-colorfulness patches that go around the spectrum every so many steps. And we take the spectrum of the light that comes off of those, and then we can measure that amount, calculate it, and compare it to a reference light at the same temperature as the light we're examining, and that gives us a number. In the simplest form, it's 8 patches. There's also an additional 6 patches, which are generally not reported by the lighting manufacturers because they're harder to do lights. They're more intensely colorful and therefore are more difficult to achieve and to get good results from using some kinds of lights. And remember, CRI was originally defined for use with fluorescent lighting. And I'm sure you're familiar with all the different kinds of fluorescent where you can see it pink or green or blue or white. And so you can see that with the fluorescent lights, it was very difficult to get all 14 patches looking right. So the 8, well, was easy to do, gave good numbers, so most of the people report that. Recently, a proposal's been made for something called CQS, which is designed to replace CRI. CRI was based upon kinds of equations and color formulas which aren't used anymore. CQS was using more modern equations, but the idea was to give you a similar number to what you were used to with CRI. So you had a number going up to 100, where 100 would be a really great job of exactly meeting the same results as your reference light. It uses 15 patches. They're all very highly colorful patches because they are harder to do. And so therefore, if you can match CRI, you might not be do as well as CQS, but if you can do really good on CRI and CQS, then you have a really good light. But again, with these patches, it doesn't tell us one other thing about the light, which is how smooth is the spectrum. In this slide, you can see on the right top, we have a spectrum of a light which is smooth. There's a few bumps in it, but they're generally smooth bumps, more like rounded hills rather than a relief map of the Sierra Nevadas or the Rockies. On the one below, the HID, we're looking at a side view of the Rocky Mountains here. I mean, look at all the peaks and valleys and things. And when you're trying to profile a camera, then where those peaks fall may fall in spots where the sensitivity of the camera may change just slightly, quite a bit, with just a slight change in that peak or that valley, and it can cause problems in making a profile. So let's see, I'm not sure at this point. I'm going to turn it back to Doug, who's going to take you through some test samples we did with these new lights that we're talking about.
That's exactly right. And this is getting to the question of how does the lighting spectrum and these metrics, how do these correspond to the capture and the profile process that actually turns the lighting falling on the subject into a picture? Because ultimately, most of the people on this conference, most of the people on this webinar will be here to take photos or will be interested in recording that light permanently. And the lighting quality needs to be explained in relationship to the camera and the profile to really get that final product. So here's some testing we did with 3 different light sources. The first is Daylite LED. You can see the final photo in the top left corner. You can see the spectrum in the top right corner. And you can see a readout from Robin Meyer's Spectrashop software in the bottom right. Robin, can you give us just a few words about how you generated the top right and bottom right?
Okay. The top right is actually measured from the light itself using a spectrometer. In this case, it was an i1 Pro 2. No, an i1 Pro, I'm sorry, this one. And it's automatically calculated in the lighting tool of Spectrashop. And you can see that it gives you the CCT as well as it gives you the color index for those 8 basic patches, the color index for all 14 patches, and then the CQS down below for its 15 patches. And in the center of each of these colored patches, you can see the test, how that color would do under that test light, and the outer part is how that color appears with the reference light. So if there's a difference, then it shows it's not doing as well in that color range.
So here on this light, this is a standard consumer daylight LED, and we notice it does live up to its name in the purest, truest technical sense. That is, it is marketed as a daylight balanced LED, and as Robin's measurements in Spectrashop show, it is more or less around daylight. Daylight is either 5500 or 6500, depends on what time of day and how you're taking the measurement. But the point is that if this was being marketed as daylight LED, it is absolutely daylight color balanced. However, if we look at the spectrum, we look at that strong peak here and a strong valley here, and we look at the CRI and CQS values, it's not an especially good light for color reproduction. Right? It is balanced. That is, the average sort of weight of the spectrum is right around 5500, but it's a pretty poor light overall. And this is not to get down on this light bulb, because of course it's a consumer grade bulb, and its primary purpose is to be inexpensive and easy to make and to have your kitchen look good. And for that application, this is probably more than fine, but it's not especially suitable for careful, high quality, FADGI compliant or metamorphosis compliant color reproduction.
In general, the number has to be above 85 in order to be accepted as a good quality light.
And like everything is relative, right? So 70 is definitely better than 60. 85 is definitely a decent sort of threshold to say, hey, this is pretty good, but the higher we can go, the better. And here we have the Northlight HID, Northlight's historic system that is a little bit larger and heavier. You may well know the Northlight brand because of the HID. They are very popular and continue to be popular, especially amongst people shooting with scan backs. Scan backs require a lot of light, and HID stands for high intensity discharge. They are very bright lights. And what you see here is that as a purpose-built cultural heritage reproduction color accurate light, it does in fact live up to that standard, and it provides a 98 for CRI and 97 for CRI 14 and 98 for CQS, or in summary, very good quality as far as the metrics go. We do want to pay attention up here at two things. One is the spectrum. The spectrum is not nearly as peaky and valley-y as the night daylight LED. I don't know if those are correct technical terms, Robin, pikey, spiky, and valley-y, but they do have some, right? We do have some peaks here and some valleys here, and again, another peak and another valley. And they are fairly abrupt and fairly tight, so they are a little bit more Sierra Nevada than gentle rolling hills. The second thing we want to take a look at is, and this will come back later for us, the color balance of the HID light was around 35, 36, 3700, so not very close to daylight. In contrast here, if we look at the DT Photon, which is the most recent LED here that we're talking about, this LED maintains that same high CRI, CQS values, 98, 97, 98, but its spectrum is rather smooth in comparison. And this is not because we're averaging things together, right, Robin? This is straight out of the mathematical measurements of each point of the spectrum, done in the same way that this is done. It's just an inherently smoother spectrum.
That is correct.
So the spectrum is a little bit smoother, and look at the color balance. The color balance is very, very close to 5500 Kelvin. So it has the daylight balance of the daylight LED that we showed here, the consumer brand, and has the high CRI and high CQS of the HID, but without any of the spectral jitter or spikiness. And here is really one of the take-home from this webinar. If we presented them in a very careful order. If all I had done was show you the daylight LED, you probably would have gone, yeah, that looks about right. And one of the reasons for that is that our eyes are highly, highly adaptive. Right? You look at any image containing a generally neutral scene and some things that you think you know the color of, and your eye will tend to correct the scene visually so you perceive it to be what you'd expect. That is, you saw the orange, it should be around orange. You saw the lemon, it should be around lemon. Now when we put them all up side by side, your eye can't do that to you anymore. And so now you see some of the more subtle variations. For instance, between the daylight LED and the DT Photon, you see the red of the tomatoes is dull, right, in the daylight LED. So if we look back at the daylight LED, we can actually look at the spectrum We can look at the CRI measurements, and we see that TCS09, the red patch here, shows the resulting color from the spectrum as being undersaturated, right? So we see a not strong enough red, and we see that manifested here in the direct comparison. So, how does this relate to profiling? Well, these are the shots without a profile applied, and we can improve the quality of any camera lighting combination, whether it's a consumer LED and a point and shoot, or it's a digital back, medium format digital back, and a DT Photon. We can improve the quality or the resulting accuracy, I should say. We can improve the resulting accuracy by profiling. The thing is, though, profiling works best on smoother spectrums. And so here what I want to do is we've compressed these down to being the daylight area of the spectrum. Sorry, I misspoke. We've compressed these down to be the visible area of the spectrum, so we've cut out the infrared and UV. And here are the spectrums of the DT Photon and the HID, both in black lines. What I want to show you is sort of a visual metaphor for what I mean by it's easier to profile smoother spectrums. This is not going to be, in the strictest sense, a technically accurate demonstration, because this is not, in fact, how we profile cameras, but it's very visually illustrative. So just imagine that the process of profiling is sort of like pushing up and down parts of the spectrum with a really fat finger. You don't have nuanced fine-grained control. All you can do is sort of shove or pull on very large swaths of the spectrum at the same time. So for instance, over here on the DT Photon are purplish blues. These are underexcited. These are too little energy. So we'll just boost the camera response up a little bit in that area. Up here in the greenish yellows, you can see we have too much response, so I'll pull that response down. In the deep reds, we have too much response, so we'll pull those down. We'll try to do the same thing over here on HID. That is, we'll pull up blues, now the cyans, and now it's kind of a hard choice here because our green blues, our greens, and our green yellows are all different responses. Same thing with the reds. Where exactly do we place that? But we will do our best to make a good faith effort there to profile both of them. Again, this is not actually how profiling works. You don't play with the spectrum directly, but it's a good metaphor. And here you can see the result of that metaphor. The DT Photon is easy to push and pull on the various parts that aren't perfect because no light source other than the sun itself perfectly matches the sun. And as we push and pull on the HID, we do not get as good of a response as when we push and pull on the DT Photon. Again, because the spectrum itself is more jittery, it's more spiky. It's harder to make really fine-tuned corrections with profiles. If you've ever been in a situation where you've been doing in situ profiling, you've probably experienced this for yourself, that as you try to correct for this yellow-green patch over here, well, this green patch over there also goes out of whack as a result of correcting the yellow-green. That sort of nuance change is very hard to affect consistently in profiling. So let's talk about profiling, what our options are. So most commercial programs, including Capture One Commercial, that is the standard version of Capture One, provide profiles for the cameras they support that are general purpose. They are meant for general purpose commercial photography for people who are taking pictures of their children, their spouse, the locations they visit, or commercial photographers to shoot jewelry or to shoot fashion or shoot portraits. And they are meant, therefore, for pleasing color. In those applications, we certainly don't want a red dress to turn purple, but we would rather have skin tone that looks pleasant than necessarily have every element of skin be perfectly and faithfully reproduced, because that may not be the most pleasing way of presenting that subject matter. In contrast, you can do an in situ profile, meaning that you take profiling software, you take a photo of a known color chart, and you profile it using, for instance, basic color. Full disclosure and shameless self-promotion. We are a basic color dealer, and we are very happy to sell you a copy of basic color and step you through its operation. And doing in situ profiling will create doing an in situ profile will create a profile which is meant only for accuracy. You shoot one target in one setup, you threw that target into the software, it pumps out a profile, and you then use that profile at the time of capture. The difficulty with in situ profiling, what we found over and over again with our clients, is that it is time consuming, it is complicated, and it is very easy to mess up. If you do not do in situ profiling perfectly, if you mess up one thing, it can actually produce a profile that's worse than not profiling at all. It is definitely possible to do correctly, and in fact, I spent about 8 hours up with Robin Myers, who's on this call, that Robin Myers. And Robin, we spent 8 hours working on those profiles, and me trying to sort of throw myself at the altar of your wisdom of making profiles and learning some of your tips and tricks, and really trying to do the best job of learning profiling. And I got to tell you, after 8 hours, the number one thing I still learned from that process is it is not simple, straightforward, or error-proof.
That's correct.
And by the way, if you would like any consultation on in situ profiling, I think there's very few people in the world that would be able to provide you the same kind of consultation that Robin Myers would be able to do. So if you're doing in situ profiling, that's a great way to go. That said, because we know the cameras and the lights that we use in our system, we have created profiles for you. And we've not just done that by shooting one target one time and seeing what comes out of it and then hoping the numbers are right, or worse, validating those numbers on the target that we used to create the profile in the first place. Instead, we've shot many targets under many setups with many captures, and we've run those through with expertise. The phase 1 color scientist, Niels Knudsen, has run these through a variety of tests, a variety of profiles to make sure the profile created is both accurate and well-balanced, that it's not susceptible to sort of jitter or error, that it's not going to be as finicky as you change minute things like the angle of illumination by a few degrees. It is a very robust profile. And we do those for our cameras and lights, which means this new LED that we're producing with Northlight is one of those lights that is profiled and just comes with a profile built in. So we talked a little bit about what color is. We talked a little bit about how to measure or quantify the quality of the spectrum. We talked about how that spectrum, especially its smoothness, interacts with capturing and profiling. And so now we should talk about closing the loop. That is, all right, we've put our object down, we've taken a picture of it, it's up on screen, what now? And so proofing in general is that process of checking your work, of making sure that the work is correct and accurate. And proofing can be done, generally speaking, in two ways. You can do it numerically, where you run the resulting file through some sort of analysis software, or you can do it visually. And you can do it visually either by judging on the screen against a capture of a target that is perfect, and then comparing those two, or you can compare visually to the object itself. And so real quick, I'll just back up and say that the numeric method and the on-screen visual method are both covered in our DT webinar called Process Control. That's available for free on our website. We're not going to spend any time on that today because we already covered that in that webinar. So that third method is what I'd like to talk about now, and that is visually matching the object in front of you to the monitor. Not necessarily to make corrections, but more so to check the work that you've done to make sure that you haven't gone off on the garden path. And this has been historically a major, major challenge for photographers. And the reason is you have to have a closed loop for this to work well. And by that I mean you need to have the capture lighting, capture device, capture profile all working together. You need to have the monitor profile, and proofing light all work together. So let me give an example of this on where this would have been challenging in the past. Here is the Northlight HID. Again, we talked about the CRI and CQS are quite good at ignoring some good but not great spectral attributes. That is, it's kind of smooth, but it's not as smooth as it could be. It's still a very high quality light. So the resulting capture, if you take a picture, you look at the numbers are going to be very accurate. But if you tried to visually match the monitor to the object in front of you, being illuminated with that light, with the Northlight HID, you'd have a real bear of a problem, because look at here. Again, the color balance of that light was 3600 Kelvin. The accepted practice for monitors is a complicated topic you can get into a strong dispute with somebody about, but it's either going to be 5500 or 6500. In almost no case is anyone going to recommend running your monitor at a calibration of 3500 or 3600 Kelvin. So the light hitting the object and the color balance or color temperature of the monitor are going to be drastically different. And if there's two things we need for good proofing, we need a good quality of light, and we need similar or identical color temperatures, or effectively identical color temperatures. And that's not possible with the HID. Here with the DT Photon and with truly daylight balanced LEDs that are both good in spectrum and balanced towards the same towards the same color temperature as a monitor profile would be, we can close that loop. And so now the capture lighting and proofing lighting can be the same actual light. Not the same technology, it can be the same light. You can look at the object on the copy stand or against the wall, look at the monitor, and have them match in color balance and in spectrum. And when we look at the capture device and capture profile, those are tied in now to the capture lighting with our system because we are creating both the hardware for the capture, the hardware for the lighting, and we're doing the profiling of the capture device. We put monitor here and monitor profile in green because, of course, we don't manufacture monitors, but if you're using a high-quality monitor like an AZO or a very good NEC driven for color reproduction, then that helps close that loop further. Now, we should absolutely say and enforce and really emphasize this heavily that you will never get a perfect match between those two things. I have worked a lot now with Robin and with David Christensen of Northlight, worked very extensively at narrowing in as many of these variables as possible to see what the sort of limit of human matching can be. That is not human matching, what the limit of these two what the limit is regarding trying to match the object to the monitor. And the answer is because of a variety of things, because the monitor is an emittive light source, and because the object is going to be reflecting light as opposed to emitting it, because we have very context-sensitive vision systems where if you look at a monitor with a generally dark room behind it, and then you look at the object and it's on a white background, it's going to look very differently than if the object's on a black background. And if you don't have an uncropped version of that image on the screen, you're probably going to let that influence your vision system. It is incredibly hard to get a perfect match. So what we're talking about here is closing the loop down, trying to get as few variables as possible, trying to get the best match as possible, so that we can reasonably expect to look down at the object, look up at the monitor, and have a pretty darn good match. Robin, would you like to say anything further about the difficulties of making that perfect? Because I know it was a very difficult concept for me to fully accept because I'm a perfectionist and I want to see the exact same dang thing in front of me on the left and in front of me on the right. And no matter how good you close that loop down, right, you cannot make those perfectly match.
That's correct. And as you touched on, the surround is very, very important.
Could you explain what you mean by the surround?
The area around the objects that you're looking at. For instance, the fruit that we had there was on a white background, and that's going to change the appearance of the fruit, and then if we had it on a black background, because it also affects the shadow reflections and so forth, as you're going to touch on later. So it's a very complicated thing, and if you put it on a screen, then you've got, quite often on your screen you've got a picture of your kids or something, or your favorite vacation spot around on your background, and so that's going to affect your vision of what you're looking at in the window. So you have to go to things like turning all of your backgrounds to grays, putting grays or blacks around around all your screen objects and things, and it gets to be very complicated and quite frankly almost impossible to control all the variables. So you come as close as you can, but you don't go crazy trying to get it perfect.
Yeah, and so that numerical variation, that numerical proofing method then becomes a good sort of second point of check. And if the visual match on screen, the visual match between the screen and the object, and the numbers all agree that you're doing an excellent job, those are sort of a trifecta of approval that your color workflow is accurate. One more quick example of this that's very common in commercial photography, that's very common in museum photography, is that people will use strobes, and I'm not here to disparage strobes. Strobes are a very good solution to a lot of problems or a lot of situations. They're the best option to go with. But strobes have one major limiter, and that is you don't proof using the strobe. That is, if you shine light, the light that's shining out when you take the picture is an instant, very, 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 very fast strobe hit. And the rest of the time you're using a modeling light that's a completely different lighting technology, different color balance, different color temperature, as well as a different spectral output. And so you can't look at the object on the table being illuminated with the modeling lights and expect that to match even reasonably close to the result that you see on screen, even if the result on screen is accurately captured. You're comparing, in this case, apples and oranges. So that brings us to our last sort of point on this topic, and while I get to it, I'm going to put back on the screen the question slide. So if you have any questions on this section, we would encourage you to put those into an email right now. And the last thing I want to say in this section about lighting technical and proofing is that we are considering as a company, Northlight and DTDCH, we're considering creating a actual proofing booth using the DT Atom LED technology. And the reason we do that is because, if nothing else, when you actually go to do that sort of color critical analysis and color critical proofing, you probably don't want the object still sitting on the copy stand. You probably want it up at a nice viewing angle. You want it illuminated from a good angle with sort of a hood around it so it doesn't interfere with the monitor. And you probably don't want to have to sort of stand over the copy stand to do that. So we are considering taking that technology and putting the same LEDs, the same specifications, same calibration, same consistency into a formal proofing booth. If you're interested in that, we would love to hear from you because it is a completely different thing for us to do. We're a little bit nervous about going into an entirely different area. So if we see a lot of demand for that, if a lot of people say, hey, you know what, that sounds like a good idea to us, we're not necessarily committing to buy one, but we'd definitely be interested in potentially hearing about that more, then please let us know, because if we don't hear anything like that, we'll probably not move forward with that project. So, Allison, do we have any questions that have come into the aaw@digitaltransitions.com account?
Not at this time.
Very good. So what I will do is I'll keep going here to the next section. And if anybody has questions on that first section, we will be glad to address that after the creative lighting section. This morning we had something like a dozen questions, but I know we added a little bit more information in the slides and covered some of those as we went now in the second session. So just possible we preemptively answer all your questions. But again, I hate talking into a vacuum, so please feel free to email in any questions, whether you think they're silly or not, or if you think they should be answered or not, just send me in a question. All right, so I'm going to be switching over now to the creative lighting section. So Robin's role is largely now to wait around in case there's any questions on the technical side, because this is going to be an area that is more creative and less technical. And what I'm going to do is turn on my web camera and switch over our setup to a real-time demonstration. We're going to talk about enhancing texture. We're going to talk about lighting highly reflective or highly glossy material. We're going to talk about rim light. The topic of enhancing texture is basically using one light or a higher lighting ratio, uneven light, at a lower angle in order to increase the perception of texture. Here is an example on the left and right. You see standard lighting and then this textural enhancement treatment, which is basically raking light from one direction. We're going to make sure to offset the fall off so that the painting or item doesn't look darker on the side away from the light. And our golden rule here is going to be that the lower the angle, the more we increase texture, and we cannot forget an LCC or an even fielding. Rim lighting is a sort of theatrical style of lighting where you're lighting from behind the subject matter, and that helps to enhance the edges or borders. It helps to bring out things like, on this particular subject, hair or texture along the surface, and it can really add a little bit of drama to the image. The golden rule here is going to be very careful of flare, because you're pointing a light towards the camera, and don't forget the bounce, because if all we do is light from behind, the front of the subject is going to be very, very dark. Third topic we're going to cover is how to light highly reflective lighting. How to light highly reflective objects. And so we'll be going step by step, tutorializing, going from the left image to the right image, where one of them, the left image, is very specular and very harsh, and the right one is very soft and very global, very soft light. And the golden rule here is going to be counterintuitive. It is, don't light the object itself, light what the object sees. Don't think about lighting the object directly. Think about lighting the surfaces that are being reflected in the gloss or reflective surface of the object. So without further ado, let's get down to the step-by-step. And so I want to briefly introduce the equipment we're working with here, so everybody sort of, because you're not physically here, might help to sort of get a grand tour. We're in our New York office where we do demonstrations and R&D. And here we have the DT Atom. This is a tabletop copy stand. So the table surface here is just a standard generic table. And this is the DT Atom in front of me. It has two arms coming out from the sides. These arms provide a static position for lights. This is the DT LED Photon. Those lights can be removed from the arms, which we will do throughout the presentation today, in order to put the lights at different places. but when you want them to be in a standard angle, you lock them into the holders on the arm so that they are always in the exact same spot. That helps a lot with consistency. Very good. So here we have a painting, and right now we're evenly illuminating it. That's 2 lights. We're a little bit lower than 45 degrees, but we're in a generally normal photographic environment here for reproduction. And we will open up slide view. And slide this into a good position. And we will make sure that it's in focus. Very good. And we'll give it a standard capture here at maybe F11. So here is our capture with standard lighting. And as you can see, if we zoom into 100%, we get very, very good detail, but not a lot of texture. We see the cracks, but we see them as very flat lines. We don't get a sense they're actually three-dimensional warbling of the actual object. And I do apologize, I'm not a painting conservator, so I'm sure there's a better terminology for that, but all we see is sort of a very two-dimensional static set of lines. If we want to enhance that texture, for instance, we want to document the state of the actual painting surface for conservation treatments before and after, or to do research, or to examine, for instance, the style of a particular painter and the way that they laid down the paint, we would need to then enhance the texture of this. So what we do is we basically turn off, in this case, one of the lights. So I'm going to do that now. So the light that is a little bit off camera to the right is now off, and the light is only coming from the left side. And so what we'll do is we'll grab a capture here to show you the in-progress work, and that is the fact that it is both darker, because there's only one light firing now, and because the light is falling off across the subject. So it's a little bit darker at the bottom than it is at the top. What we're going to do is we're going to we're going to apply a even fielding. So this is just a standard piece of non-glossy matte board. And I'm going to lay that on top of the object. If we were doing very if we were doing very expensive or very unique or very fragile artwork, of course, instead of placing this on top, we could place it against a wall and hold the whiteboard in front of it by a couple inches. Or for an CompuStand environment, we can use a white background to start with, shoot that, then place the artwork down and shoot it. So we don't have to make contact with the surface. In this case, it is very important, and I want to treat with lots of respect, but it's not a Van Gogh. Here we will capture the whiteboard, and we will take this whiteboard and analyze it. And we right-click in Capture One and say Create LCC. We then take that LCC, that stands for Lens Cast Correction. It's basically our version of even fielding, meaning look where the light is falling and correct for that. And we'll apply that LCC to the original image over here. Now, because there's only one light on, we would want to correct the brightness here. I will do so visually in this case. You could also do it numerically using an object level target. That would work by just dropping in another target. Capturing it, and then using these values here in order to establish exactly how bright it should be. Here I'm just going to do it quickly visually by saying that looks about right, because the main point here is just to show you the texture. So on the right side, that LCC or even fielding has resulted in not having an uneven amount of light across the field, right? If we look at the left and right, before and after we apply the uniform light, the top part of the painting was more or less correct. The bottom part was darker. By applying the even fielding, it's the same, so we don't have a visual fall-off of light, but because we only have light coming in from one side, each and every peak and valley in that painting is going to be rendered with the corresponding shadow. And so there's a lot more tactility, a lot more dimensionality, a lot more visceral texture in this image. It is the exact same object, but simply by creatively lighting it from the side, from more of a raking angle with only one light, we get a lot more textural enhancement. Let's do the same thing here, but let's do it with a different object. This is not just good for paintings and paint strokes, it's good for a large variety of material. Anytime you want to see more of the dimensionality or texture of an item. So, I know a lot of libraries out there do copy work of letters, envelopes, notes, that sort of thing. If we look down in here now, we will notice just a tremendous amount of texture. Let me shoot this with one light back on, and with the even fielding then turned off so that we're not trying to correct for one light. We'll be able to compare and contrast the results of these two. So if we look in here, we see a very similar subject matter, but one with a lot more texture. And so any crevice, any dent, for instance, this right here is just sort of a conditional issue. It's a very small fold or a very small bend or ding in the paper. We see that crevice a lot more here because, again, it casts shadow that isn't filled in by an opposing light. Dimensionality of the stamp on top of the envelope, the dimensionality of the items fraying off the sides. In the currency, we see a significant difference showing the amount of folding, wearing, and tearing. And depending on, sort of where in the institution you are coming from, depending on what your job and role is, you may be looking at this and going, oh my gosh, I would love that. Or you may be looking at this and saying, but that's not how the object looks. And the whole point of doing this webinar was that we've done in the past process control webinars about how to do things by the number, how to do things absolutely technically accurately. And that's not always the right answer to the question, right? Sometimes the question is, how does this, can I get a better sense of the texture of this object? And if that's the question, then the lighting on the right is actually more useful, even if it is in some ways less true or less accurate to the object. So very frequently we would see our clients doing both of these for a given object, right? Shooting the standard, too light, even light, and then also a textural enhancement, because if we label that correctly and we present it correctly to the user, it provides a different sort of depth of information, I guess pun intended, a different depth about what that material looks and feels like in person. All right, so what we have shining on here right now is not what I want. I want to show you standard sort of generic front lighting for this object. So here are two lights placed in front of and sort of generically angled up from the front of the specimen. And what we see here is that it's really a really dull, flat light. Right? There's not a lot of the specimen that's kind of coming out. Now, again, if the goal is purely documentation, that might be the appropriate thing to do. But we're trying to add a little more drama than this is kind of flat, dull light, right? So let's take a look and see what we can do step by step to make this a little bit more dramatic. I'm going to turn the front light off and turn on instead a rim light. A rim light sort of by definition needs to be located behind the subject, shining towards the lens, towards the subject. As a result, as we mentioned in the golden rules here, it's very important for us to not have, some sort of hood or some sort of protection over the lens to prevent flaring. Here's the rim light. Lots and lots of drama there, but of course a lot of brightness on the legs and the thorax. Not where we're ending, this is just a step along the way. And now you can see it'd be very, very easy to get flare in the lens. If my lens is not properly shielded, I will end up with flare coming into the lens. Anytime you're lighting with a light that sort of shines directly into the lens, you might end up looking a little bit like J.J. Abrams in that first Star Trek movie where there's just flare all over the place. Flare, by the way, can manifest as very obvious shapes like starbursts. It can also manifest as just a lowering in contrast. So we want the background of the shot to be black. Here you see the flag that I've introduced. That's just using a standard magic arm to place that into the scene. Now, I'm going to place it at a little bit of an angle, and the reason is I'm going to also turn on a side light. The side light's just going to come streaming across that thorax and make sure that we're not so one-sided with the light. The danger of overly dramatic light is that even if we're going for the drama and not necessarily pure accuracy, we still want to be able to see most of the specimen. And so if I only have the one light coming from the back right, that can be a little bit too dramatic. So the flag, therefore, needs to be angled away from that side light. See it here where it's parallel to the object. It's seeing some of the light from the side light. Streaming on here, it's catching that background. Even though it's black, we manifest it as a dark gray instead of a true black. You just tilt that back a little bit away from that light. Now it's in its own shadow. The light here is not streaming onto here, and it stays a nice crisp black. A little bit more of a turn can't hurt. Okay. Shift the camera position over just a teeny tiny bit. Now, what else are we going to do with this? We're going to add a little bit of fill. There's a little white card. I'm going to drop it in there. This is just a piece of plexiglass being held by an A clamp. Again, there's a lot of fancy tools you can use in photography, especially for lighting. I wanted to show you conceptually how you can use some of the most simple ones to get very good results. I'll drop this in. Same thing over here, standard A clamp and a piece of plexiglass. And obviously, the shot being composed here in live view is all about you guys being able to see the whole surroundings. I would normally push into this scene very close and just crop, just move in so tight that I only see the insect, but here I'm going to let you see the surrounding areas. And I think that's pretty good. So let's see where we are. I'm going to go ahead and just triple check that focus because I moved the camera around, I moved the object around. So let's just go ahead and tweak this baby. Okay. And see how that looks. Okay. So we have the appropriate sort of rim light, and the word rim kind of comes from the fact that anything that's thin is going to have a rim of light around it. So if we look at some of the hair around this edge, this leg itself is going to have a nice rim of light. And it really brings out some of that texture on the thorax. I assume that that's correct technical term. I'm not an insect expert. We can see a lot of texture brought out there. And a heck of a lot more drama than the sort of generic front-on shot of this, the front-on lighting shot. If we need to in Capture One, we can also do a little bit of a local adjustment, a local dodge, to just brighten up that front of the object. Again, we could do even more fill. We could certainly add another light. But when we're just talking about a very small amount of change, it can be just as easy and accurate to do it here in Capture One. Normally, things like local changes, local dodges and burns would be discouraged in cultural heritage imaging. If you're doing just a purely technical image, that's bad news because you're now misrepresenting the object. Here, since we're looking for a more creative angle, you can use that dodge and burn to make sure we see lots and lots of that detail. So all in all, a pretty simple method. To very briefly recap, we dropped a black background in the form of a simple flag, being held in place by a super arm. We have one light coming from behind to the side and above, coming in from an angle right about like this. We have a second light in here that's shining light across and providing a little bit of fill because this light is coming from this direction. We want a little bit of fill on this side of the object. And then we have two fill cards, just adding a little bit of light to the front of the, which is basically picking up bounce. You know, this one is picking up light from there and bouncing it back. This one's picking up light from here and bouncing it back. Just adding a little bit of fill to the front of the object. Allison, any questions from either the first or the second section in Creative?
I've already fielded everything that's come in, so we're good to go.
Oh, you are just working magically in the background. Well, I'm glad that you are on top of that. Thank you very much. Anything you think would be of interest to the whole group?
No, it was more kind of like situation specific.
Gotcha. Very good. So now I'm going to make my most dramatic transformation of the day, and that is to take this black top, the black hard top, transform that and remove that and put in one of the prototypes we have of a product sweep, a white plexiglass sweep. So bear with me as I do that. If you need to check any emails or anything, it will be about 2 minutes here before we're ready to start taking more pictures as I switch over to a different kind of setup. Right, so here's sort of your generic version of cultural heritage imaging, where we shoot with a broad, even light. And it's okay, we can definitely see a lot of details here, but the nature of this elephant I don't think is really well brought out using this lighting. So we might take a shot like this to have a standard shot. Let's take a look at the more creative approach. So to do that, let's bring up live view. Lovely, so you see we've not made a lot of progress in this lighting. It's coming from the side, but it's just as harsh, just as specular as the previous. So what I'm going to do is actually take just one light from the side and then later on one light from underneath and craft this light using the same very simple materials, the piece of plexiglass here. What we're going to do is block off the direct light under the premise that we're not going to light the elephant, we're going to light what the elephant sees. So take a look at the ear of the elephant. As I take this away, what it sees is a small, distant light source, very specular in nature and therefore very harsh. As I introduce the plexiglass, it will see less light, but that's not terribly important. We can adapt for the amount of light very easily. The nature of the light that it sees is actually that it's looking out and seeing this lit surface. It happens to be lit from behind, which is much easier on small objects than to try to light this whiteboard from some other angle where we're going to end up lighting the elephant as well. So here it's just seeing this white plexiglass, and then we're going to also introduce a plexiglass on the other side. And now we'll notice the right ear of the elephant is starting to pick up some of that. Again, without and with. And you'll even notice that because what we're trying to do is light this card, again, we're not lighting the object directly, we're lighting this card, which is what the right side, what the left side of the elephant or right side of the camera sees, that the shadow being cast by the elephant on this piece right here, this shadow here, means that area is not actually bright. So if you're on the bottom half of the elephant looking downward, you're going to see an unilluminated area. So we're actually going to move this back just a little bit to make sure we're not casting a shadow on the plexiglass, which is actually the surfaces that the elephant's going to see, or at least as much of a shadow. Now we've taken care of two sides. Let's just go ahead and take a photo as is right here. And we see the elephant being lit with generic lighting, and then cultural heritage lighting. This is maybe just a little bit overall dark, so let's go a little bit longer of an exposure. Lovely. So we can see generic, and a little bit more creative. Just slid my fill card in just a little bit. You can see this little shimmer of light on the front. That's because I didn't perfectly place the plexiglass, so a little bit of light was shining forward onto that front part of the elephant. So I'm just going to move that forward a little bit. Very good. And now we've taken care of two sides, the left and the right, but we've not taken care of the top or bottom. So very notably, for instance, this elephant is wearing a headdress, and the headdress has very small, beady, reflective, shiny pieces of metal. And so we want to catch that. And what we're going to do is counterintuitively actually add light underneath. Right? So now we see light coming up from the bottom. Light coming up from the bottom. And now what we're going to do is we want to reflect that back down. And actually, again, I've made the faux pas that's very easy to make, because when we light highly reflective surfaces, again, the golden rule is we light what the reflection sees, what is being reflected in this reflective surface, not the actual object itself. And so I'm not going to be bouncing light back into the top. Instead, I'm going to provide a surface to the top to reflect. So look at the top of the headdress there, and it's probably the most dramatic demonstration of this concept we've had so far. And as we come in here, it's just a standard sheet of paper. This is literally just office paper. We can create a very nice surface for which the top of the elephant reflects. Again, imagine that the entire object was made of mirror, made of a perfectly reflective glossy mirror. In that mirror, you would see the location of the light. So when we light it with a small light from far away, it ends up being a specular highlight, very disruptive, very jarring. When we light it instead, when we provide it a illuminated surface for it to reflect instead that's very large relative to the elephant, it will be very easy for it to become a very smooth, soft, textural kind of light. Okay, so that is the generic piece of copy paper on top. If I was being a little bit fancier, I might put in a fully spectrally neutral piece of paper. Robin, do you sell fully spectrally neutral pieces of office paper?
No such thing.
I might put in there a more photographically oriented bounce, which of course a lot of companies make, usually office paper. And now we can see the progression. What I'm going to do now that you've seen the individual components around the object, I'm going to go ahead and crop into it and compare that across the 4 images. Actually, I guess only 3 images, so I'm just a little bit dark. And so here we see our 3-step process going from the generic light with very specular highlights to side light with left and right only to side light plus top and bottom. Now we only use 2 lights, which coincidentally and shamelessly self-promoting is what comes with the DT Photon by default. Of course, you can also get additional lights. But by using just those 2 lights, one off to the side, one coming up from underneath, and then fill cards, we've been able to accomplish what is normally a very sophisticated setup. Now, if you've been shooting museum work for 20 years, you might have looked at this and said, this guy's crazy. Why didn't he just use a light tent? And I got to tell you, I love light tents. Light tent is a very good idea, especially for an object like this. The reason I didn't do it today is because I think this, and by placing individual components in place one at a time, helps you understand a little bit more of what it actually means to light, quote unquote, light a reflective object. So if you do have a lighting tent, that'd be a great solution for this. But as you can see, you can also use 2 pieces of small plexiglass, 2 A clamps, and a piece of office paper. The most important thing is that the technique of the lighting be accurate and that the camera and quality of the light be good. The specific way that you shape that light can often be very MacGyver-y, and that's actually one of the definitions of a professional photographer is being a little MacGyver-y and knowing how to solve problems with not necessarily buying a very expensive reflector, but knowing how the light itself works. All right. So this was our last set demonstration. So I'd like to pause now for any questions, Allison. Let me put the slide back up of where to send those questions. We are ahead of the schedule that we anticipated by about half an hour. So if you do have questions, please feel free to send them in now. We will pause for a few minutes in order to accommodate them. Allison, any questions?
Sure. There was one question that was asking, are LED lights variable yet or just on-off output intensity?
That's actually an excellent question. So Robin, maybe you could speak to the development considerations regarding the variables we introduce, what problems we're trying to solve, and what the ramifications of adding more variables are.
LED lights can be controlled by varying their intensity, but most of the lights out there that dim them do not do that. Instead, what they use is they pulse them on and off, and they change the ratio of the time off to the time on, and that allows them to control the intensity. So if they're on all the time, that's the full brightness. If they're on half the time, that's the 50%. The problem with doing that is that the rate at which they pulse things can wind up creating flicker. And you can either see it with your eyes, and sometimes you can't, but then the camera can. So they quite often use the wall frequency of 60 hertz here in the United States or 50 hertz in Europe, or some multiple of that as their frequency that they pulse the lights. And it turns out those fall right into standard shutter speeds. So you can take one picture that looks bright, the next picture, same shutter speed. You can catch it on the off cycle and get it darker. So in the DT Photons, we used a continuous light, so we don't pulse it on or off. And we adjusted each light to have on the power supply so that they're all exactly the same to make the lighting very uniform from unit to unit.
So there's an element there that's a little bit like calibrating out variables, right? Like if I'm trying to teach somebody how to throw a dart in a bar at a dartboard, the first thing I tell them is stop moving so many things. Instead of moving your wrist, your fingers, your elbow, your arm, the top half of your body, and the bottom half of your body, try to move that down to just moving your wrist and your elbow.
Exactly.
Just try to move your wrist and your arm. Don't move your elbow, don't move your shoulder. Reduce the variables. And if all you're trying to do is take something and throw it far away, it doesn't really matter how many variables you have there because you have a very sort of blunt goal. If you're trying to precisely place the dart in the middle of the dartboard, you want to reduce the variables. Likewise, if you're trying to make a general purpose light, it is useful and positive to spend a lot of time adding what I would call features, like dimmability, to add the feature of changing the color temperature, which is something that a lot of high-end LEDs have, is the ability to sort of tune in a warmer or cooler color temperature. But for every one of those variables you add, you now have an additional control point if you're trying to make it precise and accurate for reproduction photography. So when we're trying to make these lights, the only goal we have is this market, is cultural heritage photography. We don't really care if people use these on movie sets because there's 20 other companies making LEDs for movie sets. We care about this. And the primary thing about this is the color accuracy, and the less variables, the more we can tune those in. Every light, right, David, is calibrated there at your factory, is tested at the factory?
Yeah, this is Robin. Yes, every light is spectrally measured and tested and adjusted to be as close as we can to every other light.
Which is not just literally testing it to make sure it turns on, to make sure that the metal is not bent or dinged. You're testing the actual spectral output using Spectrashop, using your expertise, to make sure the quality of the light in the spectrum is as expected.
Exactly.
Yeah. So that is sort of a brief answer. To be very clear, these are not the only LEDs in the world, and they're not the only answer to the question of what LEDs might you want to use. If you're trying to do portrait lighting on location for your museum, or you're trying to shoot gallery in situ shows and you want to be able to tune those up or down, or to change the light shapers, you know, for a beauty dish on a portrait shot or something, this is not the right solution for you. This is a very dedicated, purpose-driven solution. Doesn't dim, doesn't have a lot of features so much as it just has consistency, accuracy, and quality. Allison, more questions?
We've had several people ask about a recording of this webinar, and that will be available in about, we're estimating about 1 to 2 weeks, maybe sooner, but we'll see. So if anyone is interested in watching again, that will be available.
Since we do have the time, why don't I go ahead and go up to the website that would have those. That's dtdch.com. We'll be placing them along with our other webinars. This is an opportunity, if you've not watched our other webinars, they are under About Us videos. So dtdch.com, About Videos. I'm sure you'll also receive an email with that link once it becomes available. But for right now, you can actually go there and see under Live Webinars. You can see our process control webinar, our Capture 1CH webinar, our film scanning webinar, and then in 2 weeks, you'll also see this appear there. Didn't mean to cut you off there, Allison. Please continue.
That's okay. There was another question that came in about the LEDs. It says, how many individual LEDs are in each DT Photon? Couldn't the intensity be adjusted by only turning on a subset of LEDs?
Ooh, what a great question. So that's definitely you, Robin.
Yes, it could, but the part of what we did when we designed this light, it was designed to also be used as a slide viewer or a slide illuminator for reproduction. And in doing so, we needed to make sure that the lighting was as even across the entire surface for large glass plate negatives and so forth. So if you turned on or off various parts of those banks, you wouldn't be able to get that uniformity. So we wanted to make sure that that was something that we had total control on, was to make sure it was uniform. So we didn't allow for turning on and off different banks of lights.
And actually,
the number of LEDs that are inside each unit, I don't remember off the top of my head.
I mean, you could generally say that it's hundreds, not thousands or dozens, right?
Yes.
Yeah. And actually, they're not really hidden. One of the things I really like about our design is that we're not really interested in obfuscating what is in the light, right? Because we don't really have much fear of someone copying us because, again, it's a very small market in reproduction photography, and there's not been, to our knowledge, another company sort of making only for color accuracy lights. So you can actually just pop off 4 screws from the front, pop off the front panel, and look right in there at all the work that David and Robin and the rest of the crew at Northlight have done. And what I want to do real quick is show you visually what it looks like. I'm not going to take you through, an hour webinar on film scanning. Actually, as we pointed out, you can watch a webinar on that on our website. But I just want to show you when we talk about the light is intended to be able to do slide reproduction and I think more broadly transmissive reproduction. What we mean by that is that we could take the DT atom, replace the hard top with a film top, and this film top now slides forward and backwards, allowing a very, very even, very, very accurate, very low temperature light. Low temperature meaning it's physically not hot, so it won't warp the film, and you can run your film across these in various carriers. If you're interested in that, I would encourage you to contact us or to watch the film scanning webinar. All right. So again, if you have questions after the webinar or you prefer to have your questions answered privately, info@dtdch.com. Thank you very much for joining us today. Thank you, Robin, for joining us from the West Coast. Thank you for those joining us from Europe and Asia, especially given the hour. Any questions, please send them in. And thank you for your time. Goodbye.